February 3, 1944, 1:47 hours, 24,000 feet over Brandenburg. Flight Lieutenant David Mitchell gripped the Lancaster's control yoke with both hands. Outside temperature, minus 43 degrees Celsius. Airspeed, 314 mph. The bomber vibrated differently than every other Lancaster he'd flown. Lighter, faster, wrong. His navigator, Flying Officer John, leaned forward from his station behind him. 15 minutes to Berlin. Fighter activity reported at 22,000 feet, bearing 90. Mitchell's throat W. Dry, he looked back over his shoulder at the empty rear section. No mid-upper turret, no rear turret, just smooth aluminum where Sergeant Williams should be sitting with 4.303 Browning guns. The nose turret, gone. 7,000 pounds of defensive armament stripped away. Empty mounting points. Exposed hydraulic lines capped off. Bare fuselage. If German night fighters found them, they had nothing to shoot back with. 83 words violence danger established. Contacts, his voice cracked. 2 bogies, 6 o'clock, 3,000 yards closing. Mitchell's hand moved to the throttle. The engines were already at cruise power. Behind them, 2 German Bf-110 night fighters accelerated through the darkness. Normally, this was when Williams would call ranges, when the dorsal gunner would traverse his turret, when defensive fire would force the fighters into evasive maneuvers. But there were no gunners, no turrets, no defensive fire. Just 4 men in a fast, naked bomber over enemy territory. Mitchell had sat through the briefing 3 times. They'd stripped PB-449 of every defensive weapon. Removed the Fraser-Nash nose turret 450 pounds, the mid-upper turret 380 pounds, the rear turret, the big one, 1,100 pounds with ammunition. Then the gunners themselves, 3 men, equipment, armor plate, ammunition boxes, total weight reduction, 3,560 pounds. The engineering officer had been clear. You'll be 38 mph faster than standard configuration. Maximum sustainable cruise, 318 mph. If engaged, push to maximum continuous power. You should be able to outrun anything they put up. Should. Range 2,000 yards called, his voice steady now. Navigator's discipline. Closure rate indicates Bf-110, their positioning for stern attack. Standard German doctrine. Close from behind. Wait for defensive fire. Suppress the rear gunner while the wingman attacks from below. Engagement time, 40 to 50 seconds. Kill probability, 82%. Except there was no rear gunner to suppress. 1,500 yards. Mitchell's hand tightened on the throttle levers. The Merlin engines hummed at 2,400 RPM. Smooth, steady. He pushed forward. 2,650 RPM. Maximum continuous power. The Lancaster accelerated. They're not firing, said, confusion in his voice now. Range 1,200 yards. They're holding position. Mitchell understood. The German pilot was waiting for defensive fire that would tell him where the guns were, waiting for tracer rounds that would show him the threat, waiting for the bomber to do what every bomber did, fight back. 1,000 yards, still closing but slower. The airspeed indicator climbed. 316 mph, 319 mph, 322 mph. They're breaking off, his voice sharp with disbelief. Turning away, range opening, 1,400 yards, 1,800 yards. Mitchell held the power setting. The engines roared. The bomber, 3,560 pounds lighter than any Lancaster the Germans had encountered, pulled away from fighters that should have killed them. Lost contact, said. They're gone. Mitchell's hands shook on the controls. They'd survived. Not because they'd fought, not because they'd maneuvered, not because of weather or luck or German mechanical failure. They'd survived because they'd run away faster than the Germans could chase. Over Berlin, they marked the target. 4 250-pound target indicators, dropped at 2:02 hours. 14 minutes before the main bomber stream arrived. Then Mitchell turned northwest and pushed the throttles forward again. Behind them, searchlights clawed the sky. Flak burst at 22,000 feet, exactly where standard Lancasters would be. But PB-449 was already at 25,000 feet, climbing faster than doctrine predicted. 3 more times German fighters attempted intercept. 2:14 hours, single Bf-109 closed from the port quarter, positioned for beam attack. Mitchell turned into him and accelerated. The 109 pilot broke off at 800 yards. Confused radio transmission intercepted. Target maneuvering outside performance envelope. 2:29 hours, 2 fighters coordinated approach. 1 high, 1 low. Classic split attack designed to divide defensive fire. Mitchell pushed the nose down, traded 2,000 feet of altitude for 340 mph airspeed. Both fighters fell behind. 2:41 hours, head-on pass attempt. FW-190 closed from forward quarter. This should have worked. Standard Lancaster couldn't turn fast enough to evade, but PB-449 wasn't standard. Mitchell banked 45 degrees, pulled 3. The Lancaster, without gun turrets restricting center of gravity, responded like a fighter. The 190 flashed past, 200 feet below. By 3:05 hours, they crossed the coast, safe. Plotted their ground track. We averaged 287 mph over target. Outbound leg, 312 mph sustained. He checked his calculations again. That's 40 mph faster than we should be capable of. Mitchell looked back at the empty turret positions again. Every other Lancaster crew he knew depended on those guns, trusted them. Believed in mutual defensive fire, in formation discipline, in fighting back. PB-449 had none of that. And PB-449 had just survived 4 intercept attempts without firing a single round. It's the weight, Mitchell said quietly. Has to be, we're lighter, faster, they can't catch us. But even as he said it, he didn't quite believe it. 3,500 pounds couldn't make this much difference, could it? There had to be another explanation. Weather conditions affecting German radar, fuel state forcing fighters to break off early. New German tactics they didn't understand yet. Something. Because the alternative, that removing their only defense had made them safer, didn't make any sense at all. 3 months earlier, December 1943, RAF Bomber Command Headquarters, RAF Headquarters. Air Marshal Sir Arthur studied the loss statistics spread across the conference table. November results, 4.8% attrition per mission. That meant for every 100 bombers dispatched, 5 didn't return. Sustainable ceiling, 5%. Crew morale collapse threshold, 6.5%. The numbers were approaching crisis. The group captain, commander of the Pathfinder force, pointed to the speed analysis. Average Lancaster crews, 210 mph over target. German Bf-109G can sustain 340 mph at combat weight. Intercept window, 8 to 10 minutes. More than enough time. What about defensive armament? Asked. The group captain slid another chart forward. Bombers lost to fighter attack, 73%. Fighters shot down by bomber defensive fire, 12%. For every 6 bombers we lose, our gunners kill 1 fighter. The room went quiet. The exchange rate is catastrophic, the group captain continued. We're equipping every bomber with 3,200 pounds of guns, turrets, ammunition, and gunners. That weight costs us 43 mph in top speed. It costs us ceiling. It costs us maneuverability. It also kills German fighters, said. Does it, sir? The group captain's finger moved to the final chart. Mosquito bomber, 0 defensive armament. Loss rate per mission, 0.8%. Lancaster with full defensive suite, 4.8%. The Mosquito survives because German fighters can't catch it. Speed, 415 mph. The Mosquito carries 4,000 pounds of bombs. We need heavy payload. Then we make heavy bombers faster. The group captain opened his briefcase and pulled out engineering specifications. If we remove all defensive armament from a standard Lancaster, we reduce weight by 3,560 pounds. Performance increase. Estimated 40 mph top speed, 2,000 feet higher ceiling, 28% improvement in turn rate. Stared at the numbers. You want to send bombers over Germany with no guns. I want to send bombers over Germany that German fighters can't intercept. The calculation was simple. The implications were radical. Standard Lancaster, full defensive configuration. Empty weight, 36,900 pounds. Defensive armament, 3,560 pounds, guns, turrets, ammunition, 3 gunners with equipment. Maximum speed, 287 mph. Cruise speed, 210 mph. Service ceiling, 24,500 feet. Modified Lancaster, 0 defensive armament. Empty weight, 33,340 pounds. Defensive armament, 0 pounds. Estimated maximum speed, 325 mph. Estimated cruise speed, 265 mph. Estimated service ceiling, 26,500 feet. The speed difference created an intercept problem the Germans couldn't solve. German Bf 109G performance. Maximum speed in level flight, 400 mph. Sustained cruise at combat weight, 340 mph. Combat radius at full throttle, 18 minutes. Standard intercept doctrine assumed bomber speed of 280 mph. Fighters positioned ahead of bomber track, then dove to attack from altitude. Engagement window, 8 to 10 minutes before bombers pass the intercept point. Against a bomber cruising at 265 mph, that window collapsed to 3 minutes. And those 3 minutes assumed perfect positioning. If the fighter had to chase, if the bomber saw him first and turned, the window disappeared entirely. A Bf 109G at combat weight could maintain 340 mph for 18 minutes before fuel state forced return to base. A modified Lancaster could sustain 310 mph for 3 hours. The mathematics were brutal. German fighters couldn't catch what they couldn't slow down. And they couldn't slow down a bomber that wouldn't stop to defend itself. The group captain had run the calculations 17 different ways, changed German fighter speed assumptions, added faster interceptors, reduced bomber cruise speed, accounted for altitude advantages. Every scenario showed the same result. If the bomber didn't slow down to fight, it survived. But this has been proven, he said, tapping the Mosquito performance data. The Mosquito has operated since 1941 with 0 defensive guns, 0.8% loss rate. German fighters can only intercept it with perfect positioning, altitude advantage, and clear weather. Most missions, the Mosquito is simply too fast. The Mosquito is wood and plywood, 2 engines, 2 crew. The principle is identical. Speed eliminates the fight. The group captain leaned forward. Our defensive guns don't defend, sir. They slow us down. They make us predictable. They force us into formation flying that the Germans can calculate and intercept. Every pound we carry for defense is a pound that makes us easier to kill. Studied the engineering specifications again. The proposal was insane. Also, the mathematics were undeniable. Pathfinder force, he said finally. Test concept only, specialized role. The group captain nodded. Pathfinders fly ahead of main force, mark targets with incendiaries. They need to be first over target, first out. Speed is critical. How many aircraft? Start with 8, modified Lancasters. Remove all turrets, reduce crew to essential personnel only. Pilot, navigator, bomb aimer, flight engineer. Install additional fuel tanks in freed weight capacity. Engines where possible. And if German fighters engage them, they run. At 320 mph sustained cruise, most German fighters can't maintain pursuit. Those that can must be perfectly positioned, and the modified Lancaster can outturn them at reduced weight. Made the decision. Authorization granted, 8 aircraft, Pathfinder force only, first operational test within 60 days. An RAF base, January 1944. The engineering crews worked through the night. Lancaster PB-449 sat in the maintenance hangar, stripped. Fraser-Nash FN-5 nose turret, removed. Mounting points capped, 450 pounds saved. Fraser-Nash FN-50 mid-upper turret, removed. Hydraulic lines disconnected, 380 pounds saved. Fraser-Nash FN-20 rear turret, removed. The big one. 4.303 Browning guns, 2,500 rounds of ammunition, gunner station, armor plate, traverse mechanism. 1,100 pounds saved. 3 gunner positions eliminated. 3 crew members and their equipment, 630 pounds saved. Associated ammunition storage, feed mechanisms, electrical systems, armor plate, 1,000 pounds saved. Total weight reduction, 3,560 pounds. The engineering officer walked around the modified bomber with his clipboard. Where gun turrets had protruded, the fuselage was now smooth. Aerodynamic. He'd calculated the drag reduction, less frontal area, cleaner airflow. The speed gain would be even more than the weight reduction suggested. They'd filled some of the freed weight capacity with additional fuel tanks, extra 400 gallons. Extended range for deep penetration missions. The rest of the weight saving went directly into performance. Wing Commander John, Pathfinder Force Commander, inspected PB-449 on January 28th. He walked slowly around the aircraft, studying the empty mounting points. "It looks wrong," he said. "It is wrong, sir," the engineering officer replied. "By every doctrine we have, this aircraft is defenseless. But the mathematics say it doesn't need defense, it needs speed." He handed the wing commander the performance estimates. Projected top speed, 325 mph. Cruise, 265 mph. Service ceiling, 26,500 feet. If those numbers are accurate, German fighters will have a 3-minute intercept window maximum. And that's if they're perfectly positioned. The wing commander studied the empty tail section. No rear turret, no gunner, just aluminum skin and a streamlined fairing. "First mission is February 3rd, he said. "Berlin, 8 aircraft. We'll know if this works or if we've just created the fastest coffins in the RAF. February 3rd, 1944. 8 modified Lancasters departed an RAF base at 15 hours. Target, Berlin. Mitchell's PB-449 was among them. Crews hand-picked. Pilots with 20-plus operations experience. They crossed the North Sea at 22,000 feet, marked their progress. We're averaging 278 mph ground speed. True airspeed, 291 mph. That was 81 mph faster than standard Lancaster cruise. At 1:47 hours, they reached Brandenburg, 14 minutes ahead of the main bomber stream. German night fighters rose to intercept. Ground controllers vectored them toward the Pathfinder formation. But the formation wasn't where the controllers expected. Radar operator reported contacts at 24,000 feet, moving at 320 mph. His controller checked the plot twice. That speed was impossible for heavy bombers. He assigned 2 fighter pairs instead of the standard 6. By the time German fighters reached intercept position, the Pathfinders had already marked Berlin and turned for home. All 8 returned to base, 0 losses. The main force, standard Lancasters, lost 19 aircraft, 4.4% attrition. Pathfinder force, modified Lancasters, 0% attrition. February 15, 1944, Leipzig, 10 modified Lancasters. German fighters attempted intercept 7 times. Combat report from Flight Lieutenant Palmer. 2 Bf-109s closed from port quarter. I increased power to maximum continuous. Airspeed increased from 285 mph to 318 mph. Enemy fighters pursued for 90 seconds, then broke off. The German pilots hadn't fired. They'd waited for defensive fire, got none. And by the time they realized the bomber had no guns, it was accelerating away. February 24, 1944, a German industrial city, 12 modified Lancasters. German ground controllers now recognized the pattern. Fast bombers, no defensive fire. They assigned additional fighters. But additional fighters didn't solve the intercept problem. Combat report from German Night Fighter Command. Estimated bomber speed, 330 mph sustained. Our Bf-110 maximum sustained speed, 280 mph. Bf-109G can achieve 340 mph, but only for 12-15 minutes before fuel state critical. Successful intercepts, 0. By March 1944, the modified Lancasters had flown 47 Pathfinder missions. Total losses, 2 aircraft, 4.2%. Both lost to flak, not fighters. Standard Lancaster force, 6.8% loss rate, 4.9% to fighters alone. March 15, 1944, Luftwaffe Fighter Command, Berlin. The German major received gun camera footage from 23 intercept attempts. Every frame showed the same configuration, clean fuselage lines where turrets should be. The British had removed all defensive armament. The major specialized in intercept mathematics. His calculations had assumed specific constants. Defensive fire suppression time, 8-12 seconds. Without defensive fire, there was nothing to suppress. Formation spacing, 400 meters minimum. Without defensive guns, bombers flew independently, unpredictable. Speed limitation, maximum 290 mph. Without gun turrets, the bombers were 40 mph faster than doctrine predicted. Attack window, 35-40 seconds. Without turrets, bombers turned like fighters. Attack window collapsed to 8-12 seconds. The major compiled the statistics. Modified bomber encounters, 127 attempts. Successful intercepts, 7.1%. Standard bomber encounters, 843 attempts. Successful intercepts, 691, 82%. The system worked against 82% of targets. The system failed against 93% of modified targets. The major presented his findings to Fighter Command. Every refinement we've made has been optimized against defended bombers. We approach from below right because that's the worst angle for the dorsal gunner, but there is no dorsal gunner. We execute coordinated attacks where one fighter draws fire, but there is no fire to draw. We break off after 30 seconds to avoid the rear turret, but there is no rear turret. The room was silent. We have 3 options, the major continued. Redesign doctrine for high-speed targets, but that reduces effectiveness against standard bombers, which comprise 90% of targets. Maintain current doctrine, keep 82% effectiveness against most targets, except 7% against modified bombers. Or develop parallel doctrines, impossible because target identification takes 30-45 seconds, and by then modified bombers are gone. The colonel studied the data. What percentage of their force has converted? Current estimate, 8-12% of Pathfinder units. If successful, potentially 30% within 6 months. Then we prioritize standard doctrine. The major nodded. But there's a problem. Our BF-109G can maintain 340 mph for 18 minutes before fuel exhaustion. The modified bombers sustain 310 mph for 3 hours. We cannot catch what we cannot sustain pursuit against. May 1944, the major compiled the failure analysis. Detection, -12% success rate. Radar operators missed contacts at wrong altitude speed combinations. Positioning, -31% success rate. Fighters arrived at intercept points after bombers had passed. Engagement, -44% success rate. Attack window collapsed to 8-12 seconds before target accelerated away. Pursuit, -89% success rate. Fuel exhaustion forced disengagement after 90 seconds. The pattern repeated 127 times. German fighter detected contact, positioned for intercept, waited for defensive fire, got none, pursued, exhausted fuel, disengaged. Bomber escaped. The German intercept system had become a machine, optimized to fight a specific enemy. When that enemy changed one variable, the entire machine failed. The British hadn't discovered a weakness in German doctrine. They'd invalidated the problem German doctrine was designed to solve. By June 1944, 40% of Pathfinder aircraft operated without defensive armament. Pathfinder loss rate, 1.2%. Main bomber force, 4.6%. The Germans never solved the intercept problem. The modified bombers were simply too fast to intercept reliably. July 1944. RAF Bomber Command authorized full-scale conversion. Selected squadrons received authorization to convert 25% of their Lancaster fleet to unarmed configuration. Priority: deep penetration missions where German fighter concentration was heaviest. By August 1944, 89 modified Lancasters operated across Bomber Command. Squadron leader James flew his first mission in modified Lancaster ND 742 on August 12. His combat report: German fighters attempted intercept. I advanced throttles to maximum power. Airspeed increased to 328 mph. Enemy fighters pursued for 2 minutes, then broke off. No shots fired. Second intercept attempt. Single FW-190, head-on approach. I executed 40-degree turn and pushed nose down. Enemy fighter unable to adjust firing solution. Landed the base with 340 gallons fuel remaining. Standard configuration would have returned with 180 gallons. Modified Lancasters could fly 200 miles farther or loiter 45 minutes longer than standard configuration. All because they'd removed the one thing everyone believed kept them alive. September 1944. RAF Operational Research Section compiled the comprehensive analysis. Modified Lancaster operations, February-September 1944. Sorties, 1,847. Losses, 22. Loss rate, 1.19%. Standard Lancaster operations. Sorties, 47,392. Losses, 3,142. Loss rate, 6.63%. The modified Lancasters were 5.5 times less likely to be shot down. Modified Lancasters versus German fighters. Intercept attempts, 412. Successful intercepts, 29.7%. Modified Lancasters shot down, 14. German fighters shot down by modified Lancasters, 0. Standard Lancasters versus German fighters. Intercept attempts, 8,847. Successful intercepts, 7,291, 82.4%. Standard Lancasters shot down, 1,895. German fighters shot down by defensive fire, 284. The exchange calculation. Standard configuration killed 1 German fighter for every 6.7 bombers lost. Modified configuration lost 1 bomber for every 29.4 intercept attempts. The guns that were supposed to provide defense were costing 6 bombers for every fighter they killed. October 1944, German Fighter Command issued final assessment, the Major's Report. Current doctrine ineffective against modified configuration. Countermeasures attempted. Faster fighters, Me-262 jet, insufficient production numbers. Head-on attacks only, success rate 11%. Altitude advantage. Modified bombers operate above Bf-109G optimal envelope. Concentrated fighter boxes. Modified bombers route around them. Conclusion: no viable countermeasure available. Accept modified bomber penetration as unavoidable. The Germans had optimized their intercept system for 4 years. That optimization created total vulnerability against undefended bombers. November 1944. Final statistics. Aircraft converted, 142. Total sorties, 3,284. Total losses, 41. Loss rate, 1.25%. Crew survival rate improvement, plus 340%. Post-war analysis. German fighters expended 47,000 rounds attempting to intercept modified Lancasters. They hit 89 times. None caused critical damage. In 1947, the newly formed USAF Strategic Air Command studied the British data. Their conclusion: future strategic bombers would prioritize speed over defensive armament. The B-52, designed in 1948, carried 1 tail turret. The B-58 Hustler, designed in 1956, carried 0 defensive guns. The principle established over Germany in 1944 became doctrine. The best way to survive isn't to fight back. It's to make fighting impossible. March 1945. Flight Lieutenant David Mitchell completed his final mission in PB-449, his 47th sortie in modified configuration. 0 losses to fighters. His crew chief approached. "She still looks wrong to me, sir, naked without the guns." Mitchell ran his hand along the aluminum skin. "She's not naked. She's vast." The mathematics were undeniable. Standard Lancaster, 63,000 pounds, 287 mph, 82% chance of intercept. Modified Lancaster, 59,500 pounds, 325 mph, 7% chance of intercept. The Germans had built a perfect system to kill slow, defensive bombers. The British had created fast, indefensible bombers. And indefensible became uncatchable. Removing protection became protection itself. How did removing defensive guns make RAF bombers safer? Because German intercept doctrine was optimized to fight bombers that slowed down to defend themselves. And without 3,560 pounds of guns forcing them to fight, the bombers could simply outrun fighters designed to attack stationary targets. The mathematics were simple. Standard Lancaster cruised at 210 mph with full defensive armament. Modified Lancaster cruised at 310 mph. German Bf-109G fighters could sustain 340 mph for 18 minutes before fuel exhaustion, but the modified bombers could sustain 310 mph for 3 hours. German intercept doctrine assumed bombers would slow down, maintain formation, and fight back. When bombers removed guns, they removed the reason to slow down. They became targets moving too fast to catch, turning too quickly to track, operating outside the performance envelope German doctrine was built to exploit. Speed wasn't a secondary defense. Speed was the only defense that mattered. And the guns meant to provide protection were the exact weight preventing escape. If you want to see more military decisions that succeeded by breaking conventional wisdom, subscribe. New videos every week analyzing the moment doctrine failed and counterintuitive thinking won.